There are three ways to prove that triangles are congruent. If you have a triangle whose sides are that length, those three different lengths, there's only one triangle you can make from them. If you take the longer one, and then you take the middle side one. If you put it like that, well then the third side would not be that length. So you take the longer side and imagine you put your compass needle here and you put the pen mark there. If you put the second side anywhere on that circle, let me number these, 1, 2, and 3. It would be the length of number 2. The thing is, as this angle goes from bigger to smaller to smaller to smaller, notice what happens to the third side. Now, I wish I didn't just do this. But notice what happens to their third side. First, it's very long, and then it's shorter, and then it's even shorter. And let me draw it again because I drew on it so much. There's that second side. I put my compass needle here, and I make my arc. So if I put the second side this way, it's the right length, and now the third side is shorter, and then the third side is even shorter. There's only one time when the third side will be exactly that length. Because as I pivot, as I move the second side around this circle, each time the third side is going from long to shorter to shorter to shorter and shorter. They're always a different length. Only one time will it be exactly this length. That is, if two triangles have the same three lengths, 10 inches, 8 inches, and 4 inches. First, I want to make sure that's even possible. Now, any triangles I make with sides 4, 8, and 10, they will look exactly the same. Now, when I say exactly the same, let's suppose it is this triangle. Suppose it's that triangle. I can rotate it. I can rotate it 10, 8, 4. But, basically, if I took this triangle, I can actually rotate it around and it will lie right on the other one. Okay, so this is called side, side, side. Side, side, side is congruent to side, side, side. If a triangle has 3 pair of matching sides, they are congruent. They are the same triangle. Okay. Now, what if I had a side, an angle, and a side? The angle is literally side, angle, side. The angle must be in between the two sides. That is, you are given the length of the two sides, and you're given the measure of the angle in the middle. So maybe this side is that long, and we have an angle. We have the angle x, and the second side is exactly this long. This is how long one side is. This is how long the other side is, and that's the angle. Well, there's only one third side, and it has to be that one. If I draw another triangle, if this is 10 inches and this is 4 inches, well, I have my 10 inches, and my 4-inch can go here, or here, or here, or there, or can it? It must be that angle. It must be that angle. That is, it can't go 4 here, or 4 that way, or 4 this way. It must go 4 that way. And then the third side has only one option. Has to go from here to here. These two triangles are congruent. They have to be. By side angle side. They both have two sides of the same length, and the angle in the middle of those two sides. You can't say side, side, and that angle. That's not enough. That's not enough. That wouldn't work. The angle has to be in the middle. The angle has to be in the middle. So, we talked about side, 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 angle, side. Now, what about angle, side, angle? What about you have two angles? Say, here's a triangle. You have this angle and that angle, and that's the side in the middle. Okay. So now you have two angles, and in fact, I'd rather just draw it slightly differently. Let the two angles be in the base and the side in the middle. Now, if just the two angles were the same, if I were to extend AB, so basically, that's the same angle A. And over here, that's the same as angle B. The thing is that this is S prime. It's not the same as S. It's longer. But nonetheless, they have the same two base angles. In fact, if two angles are equal, so is the third one. The problem is that they're not the same size. This triangle number 2 is scaled. It's bigger. If this is 7, maybe that's 14. Twice as big. And that's where the problem comes in. But, if we say, yep, keep the same two angles, angle A and B, but make sure that this length is the same as that. That is, take this, take that, and move it closer to the left. That is, make sure, that's length S. So, move this whole piece over here. Okay, this is angle B. It's the same angle. Now, those two triangles are the same. Which two? The two that remain now. They're the same. By ASA. Okay. So, what are we saying? Let me make this crystal clear. If you have one triangle, sides A, B, and C, and you have another triangle, and you have sides A, C, B. Those triangles are congruent by SSS is congruent to SSS. You show that they both have side of length A and another side of length B and yet a third side of length C. They have the same three lengths. Every side in one triangle is paired up with one in the other triangle. Those triangles are congruent. So you have a side 1, side 2, and an angle in the middle. And you have another triangle. It had side 1. It had the same one side matched side 1. And one side here was the same as our side there. And the angle in the middle was exactly the same. These two triangles are congruent by side angle side. Side angle side. It is not enough to say, well, this has 3 and this has 4 and this is 70 degrees and this triangle has 3 and this has 4 and that's 70 degrees. No. Here they both have sides 3 and 4. 4 and 3. They make up that angle in the middle. 4 and 3. That's the angle that would have to be 70 degrees. These are not congruent. So that's SAS. Well, this one wasn't, but the one in the bottom is. And then the other one is ASA. You have a side and the other, and you have angle 1 and angle 2. If you have another triangle, I don't care if they look the same or not. If this is angle 1, that is, they match, and this angle matches that angle, and the side in the middle is the same, these two triangles are congruent by ASA. The side has to be in the middle here, and over here, between the two sides, the angle has to be in the middle. Between the two angles is a side. That's the side in ASA. Now, when you have 3 sides, doesn't matter what you put in the middle. So that's very important. That's how you prove that two triangles are congruent. That means you can put one, if you rotated and possibly flipped it, you can put one triangle on top of the other triangle. And we'll try to do some proofs, do a couple of elementary proofs. Suppose that you were given this diagram, give you an inverted triangle. You have points A, B, C, and D, and point E. And you were told that A, E, and DE are the same, and BE and CE are equal. And you want to prove that triangles AEE and DEB, AEC, and DEB are in fact congruent. Well, the first thing you might want to do in such a problem is to actually find out what where those triangles are. AEC. Okay. AEC. That's that triangle. And DEB is that triangle. So these two triangles kind of overlap. fact, maybe we'll separate them. You have ACE, and you have BDE. B, D, and E. And we know that AE and DE are the same, and we know that BE and CE are the same. But you know what? They have a common angle. Angle E equals angle E. They have two pairs of congruent sides, and in between those two sides will be angle E, the same angle, congruent angles. Well, that's enough. Those two triangles are congruent by SAS. Statement, reasons. One, you have that AE is congruent to DE, and you have BE and CE. The reason? They were given. Number two, angle A. Oh, wait a moment. We have to be careful about this angle E. Sorry about that. So sorry. Those two angle E's are not the same angle. This angle E here, it's just that part. And the angle E over here, BED, is just that part. Okay, so you know what? Forget about angle E. We can actually argue it, but that comes from something that we're going to learn later on. You'd understand it now, but what we can do is say that, so look at the very big triangle, ADE. We are told that AE and DE are equal. So the base angles are equal. Oops. Let me try that again. We have ADE, and we know that those two sides are equal. Well then, the base angles are equal. Okay, so the base angles are equal because it's an isosceles triangle. Triangle AED is isosceles. Why? Two sides are the same. Two sides are congruent. Now, we can say angle A is congruent to angle D. Base angles of an isosceles triangle are in fact equal. Okay, so we now, why am I getting caught up here? I do agree that angle A and angle D are equal. All right. There's lots of ways to proceed. Here is the cleanest way. Here is by far the cleanest way. Those two triangles that I have at the top right, I have two sides equal. I'm going to show that those third sides are equal. I'm going to show that AC and BD are equal. Well, AC is this, and yeah, we need to be given one more thing. I'm sorry. AB and CD are equal. AB and CD are congruent. So basically, I want to show that these two are congruent. I want to show that AC and BD are congruent. Well, basically, I know that AB and CD are congruent. I just add BC. Alright, so we are also given that AB is congruent to CD. So statement 2 is I can say AC is congruent to BD. And the reason is, if a line segment is added to two congruent line segments, their sum will be congruent. So now I have the third sides are equal. So statement number 3 would be triangle AEC is congruent to triangle DEB, and the reason would be SSS is congruent to SSS. Sorry I didn't see it immediately. Alright, how about we try this one? Now this triangle, actually, how about this bigger one as well? K, M, O, P, and we'll call this R. Angle 3, angle 4, angle 5. Well, that's probably not 5. This is 5 and that's 6. And I'm not saying any of them are equal to one another. Okay. And we're told that angle 3 is in fact equal to angle 6. And we are told that KR and PR, KR and PR, they're congruent. And KRO, angle KRO, is also congruent to PRO. PRO. Actually, that should be M, of course. KRM, PRO. Okay. Now, first thing I want to do, I want to draw this a little bit bigger. Bigger in this case meaning spread out more. KMOPR. And 3 and 4 and 5 and 6. So angles 3 and angle 6 are in fact equal to one another. And KR and PR are equal to one another. But we didn't really need to be given that. But I gave it to you anyways. And angle KRM, this angle here, and PRO, this angle here, they're equal. They get 2 slashes. And we're going to prove that triangle KRM something's wrong here. Yeah, actually, KRO and PRM. KRO. We want to prove that triangle KRM is congruent to PRO. Okay, so let me remove this here. Alright, there it is. So now we're told that KR equals PR and angle KRO. This angle here is equal to PRM is equal to this angle. Now we want to show that KRM, triangle KRM, this triangle here, and PRO, this triangle here, are in fact the same. Okay. Well, the first thing I'm going to say is angle 4 and 5 are equal for a couple of reasons. One, they're supplementary to equal angles. The supplement of 4 is 3. The supplement of 5 is 6. And 3 and 6 are equal. So the supplements to congruent angles. Supplements to congruent angles are congruent. So angle 4, so what I put in green, we didn't write up yet, we didn't prove yet. But right now, angle 4 and angle 6 are equal. Another argument would be that it's an isosceles triangle. So the base angles are equal. Let me not put that in green because that means we don't have it yet. Alright, so 4 and 5 are equal. Angle 4 and 5 are equal. And the two right triangles have one side in common. So right now we have AS. Well, either we get an S in front or we get an A on the end. SAS or ASA. And I think we can do ASA. And the reason is that at the very top we have those two equal angles. If I remove what's in the middle, then I have ASA. I have that this angle and this angle are equal. So I have two angles that are the same, and the side in the middle of those two angles are the same. And that's how we're going to proceed. Okay, so statement, reasons, ASA. So 1 is everything that we were given, and the reason is it was given. Now I'm going to say that angle 4 is congruent to angle 6. And the reason is supplements to congruent angles are congruent. 3 and 6 are congruent angles, and 4 and 5 are supplementary to them, so they're equal. Okay, so now I do have 4 and 5. Let's give them 2 slashes. I do in fact have 4 and 5. Okay? And I have KR and RP. I do have that one side. Now in the givens, I have that these two angles are equal. But I am going to remove MRO. I'm going to take away that. Okay, so statement 3 is angle KRM, just this piece up here, and this piece over here, PRO, are congruent. PRO are congruent. And the reason is, if an angle is subtracted from two congruent angles, their difference will be congruent. Okay. So now I'm done. I can say by statement 4, triangle KRM and triangle PRO are congruent. And the reason is A, and the side in between. ASA is congruent to ASA. They're the exact same triangles. There's no way they're not. Okay, that completes this section. It's a very important section. It's one thing to memorize the ASA and the SAS. It'd be good to understand it. But nonetheless, you have to remember that this angle in SAS has to be in the middle. And when you have ASA, the side has to be in between the two angles. Okay, good luck with this.